Hi everyone, today we'll be discussing all the properties that we'll be running through in algebra. It's a lot of writing, so just bear with me on this. The front and back is all vocabulary. When we come into class next time, we'll go through, we'll practice the vocabulary as much as possible, and then we'll start applying those properties to solving equations. All right, so first, we're going to look at the commutative property. I like to look at commutative as like your commute to and from school, or a person's commute to and from work. You follow that same path forwards and backwards. So when we talk about the commutative property, it's just the changing the order. When it's the commutative property of addition, we're changing the order of the addends. So I can add A plus B, or I can do B plus A, and it doesn't matter. I still get the same answer. When we're talking about the commutative property of multiplication, it's still changing order. It's just now we use that word factors. So A times B is the same as B times A. The next property we're going to talk about is the associative property. So we can break that up again into addition and multiplication. Associative property has us changing groups. So if you think about who you associate with day to day, you guys might have different lunches for white days and orange days. So who you associate with on your orange day lunch may not be who you're associating with on your white day lunches. So your groups might change depending on your situation and where you are. And same with multiplication. Again, we can change our groups or our symbols, okay? Or change our grouping symbols. So it's just a matter of where are those parentheses placed. The order stays the same. So I have A plus B plus C, A plus B plus C. But in the first instance, I grouped B and C together. In the second instance, I grouped A and B together. And if we think about our order of operations, we always have to do what's inside the grouping symbols first before we can take care of the outside. Then we have our identity properties. So again, we break the num to addition and multiplication. The addition property we call the additive identity. And all that means is the sum of a real number and zero is the original number. If you think about your own personal identity, you don't change who you are. You are who you are from the day you're born until the day you die. You stay the same person. You might change your look, but you're still the same person. Multiplicative identity. It just says that the product of a real number and 1 is the original number. Inverse, again, that can be split into addition and multiplication. So the additive inverse, opposite. So the additive inverse says that, where is it? It's not showing up. All right, let's get this one to show up. There we go. All right, I don't know why that didn't want to show up. All right, the sum of a real number and its opposite equals 0. So whenever we're talking about additive inverses, okay, we're going to add a positive and a negative number together, the same number, and it's always going to equal 0. Multiplicative inverse. Okay? In this case, we are talking about, let me make that pop in, okay? The product of a real number and its reciprocal. So reciprocal is where we take a fraction and we flip it. If I have A, that's the same as saying A over 1. I can flip that over and get 1 over A. If I multiply those reciprocals together, it's always going to equal 1. All right, then we go down to the property of 0. So you guys don't have this part. It was fixed on yours. On mine, it was not. So the multiplicative property of 0 just states that the product of any number and 0 equals 0. So we know that. Sometimes it's just a matter of coming up with the name of it. So anytime you multiply a number by 0, the answer is 0. And then the last property that we're going to look at on this page is the distributive property. And the distributive property says that I can take this A and I can distribute it over the addition or subtraction. So I'm basically taking that A and I'm handing it out to everyone. So I'm going to give that A to the B, and then I'm going to give the A to the C. So a number multiplied with a sum or difference gets multiplied with each addend. All right, so those are the main properties. These are the properties that we use all the time. Okay? When we start looking at equations, these are the ones that we're mostly going to focus on. But we're going to come over here and we're going to also talk about properties of equality. So these are also some properties that we see, we just don't name them quite as often. So, all right, so a reflexive property. Think about your reflection, okay? What you see, who you are, and then when you look in the mirror, it's going to be the same exact thing, okay? So it's a number that's equal to itself. We call that the reflexive property. Symmetric property. I could draw a line through it. So if I were to just draw a line, I could draw a line through. A equals B, B equals A. If I were to fold over on that line, my B's would line up, my A's would line up. We call that one the symmetric property. All right, so now the symmetric property is the order of equality does not matter. So it doesn't matter if A equals B or B equals A, it's the same thing. Transitive property. I always kind of like to think of this as a train. Transitive train. So the transitive property states that two numbers equal to the same number are also equal to each other. So if I have A equals B and B equals C, then A equals C. So this is kind of like my train cars. So A is my engine, C is my caboose, B is just all the cars in between. We could also look at them as an overlap. So if I have A equals B, so I could do this. If I have A equals B, and then I have B equals C, I have this overlap here. So I can take those, and they overlap. And we could, if we cut out the B, we'd then see that A also equals C. So it's another way to look at it. I can separate them out, right? Or I can overlap them. And we end up with that A equals C. We can cut the middleman out. There's another way to look at it. Cut the middleman out, and we're left with A equals C. All right, substitution. Now this one we do talk about a lot when it comes to solving equations. So substitution is just saying that a number is equal to an expression that can, a number that is equal to an expression can replace the expression. So if x equals y, then y can be substituted for x in any expression. Sometimes we'll see, like if you complete a math problem, so we consider this to be substitution. If I said 5 plus 2, and then we give the answer 7, right? I just substituted that 5 plus 2 with the answer 7. So we consider that to be substitution. The addition of equality. So this is where we say that if we take an expression, right, and if I add something to one side, I have to add something, the exact same thing to the other side. So if you add something to one side of an equation, you must add the same to the other side of the equation to keep it equal. You may have learned in the past about balancing the scale when solving an equation. That's what we're doing here. Subtraction of equality, it's the same thing. If you subtract something from one side of the equation, you have to subtract it from the other side. Multiplication of equality, again, the same thing. If you multiply something to one side, then you have to multiply to the other side. And then same with division. If you divide one side by something, you have to divide the other side by the same number, again, to keep it equal. So these are all of our equality statements. And then, of course, as we go through our next few lessons, we're going to look at how to justify the steps that we made using all these different properties. Again, the first page of notes are the ones that we use the most. The reflexive, symmetric, transitive, we see a little bit here and there. It's more just knowing what do they mean. And then again, we see substitution and then these equality ones used a little more often. All right, that is it for the notes. When we come into class next time, we will do some practice to help us make sure we're remembering these vocabulary words. I will see you in class.